Most deployment approval today still depends on reviewer judgment, static checks, or increasingly probabilistic tools. That works in general development, but it breaks down in environments where correctness, reproducibility, and audit actually matters. I built a deterministic code change authorization system that shifts deployment decisions from opinion to proof. Instead of asking, does this code look correct? The system asks, can we prove the behavior is equivalent under controlled execution? The problem is that current approaches don't give you a strict decision boundary. Code review is inherently subjective. Two reviewers can reach different conclusions on the same change. Static analysis helps, but it operates on patterns and rules, not actual runtime behavior. AI tools are probabilistic. They provide confidence, not guarantees. So, in practice, deployment approval becomes a mix of judgment, heuristics, and trust. What's missing is a system that enforces a decision model on reproducible proof. The core idea is to shift authorization from interpretation to execution. This system does not review code and it does not generate suggestions. Instead, it validates behavior under controlled conditions and produces one of the three outcomes: allow, block, or a state where deterministic proof cannot be established. The third state is critical because it prevents false confidence. Instead of forcing a decision when the system is uncertain, it explicitly surfaces that as uncertainty. The pipeline is deterministic by design. A code change first goes through normalization, where non deterministic elements like timestamps or IDs are controlled or removed. Then the system performs replay execution under controlled conditions. The outputs are validated against a trusted baseline, and the system produces a final decision. The key idea here is that the decision is based on reproducible execution behavior, not static inspection and not probabilistic inference. Given the same input and environment, the system will always produce the same result. The decision model is intentionally asymmetric. Allow means the behavior matches the baseline exactly. Block means the behavior diverges in a meaningful way. And when deterministic proof cannot be established, the system returns a no proof state instead of guessing. This design is important because it preserves trust. This system is easy to block, hard to allow, and completely comfortable returning uncertainty when needed. What makes this system different is not that it's smart, it's that it is strict. It is deterministic, not probabilistic. It is execution based, not static. And it enforces decisions instead of suggesting them. It also provides full auditability because every decision can be reproduced. So, this is not an improved code review tool, it is a new layer a deterministic authorization layer. In practice, this maps cleanly to real scenarios. A safe change that preserves behavior is allowed. A logic change that alters output is blocked. And a non deterministic case, like randomness or external dependencies, returns a no proof state. This ensures the system remains conservative and avoids over approving changes. I evaluated the system across 36 controlled scenarios with equal distribution across outcomes. The results were fully consistent and reproducible across runs. The goal here wasn't to maximize approvals, it was to validate the integrity of the decision model. In a real workflow, this integrates into the CI CD pipeline. It sits after validation steps like testing and static analysis and acts as a pre merge authorization gate and final decision layer before deployment. So instead of relying on a manual approval, the pipeline enforces a deterministic decision. The boundaries are strict by design. The system does not guess, does not use probabilities, and does not approximate. If deterministic proof cannot be established, it returns a no proof state. The impact is a shift towards strict deployment control. It reduces dependence on subjective decisions, enables audit ready authorization, and creates a reproducible enforcement layer. This is not smart code review, it is strict deployment control.